Welcome to Mathlink Academy, where we connect the dots. I am Mr. C, and in this unit, we're going to looking at increasing and decreasing functions, where the function increase, where the function decrease, and also look at relative extremums, local max or local mins, or absolute max or absolute mins. So let's get started. Before we get started, I want to go over a definition of increasing and decreasing functions, where the function increase and decrease, and then show you some procedures of how to find that and also how to find the relative extremums. So the first thing, let's look at a definition before we look at some examples. And so when we talk about increasing, a function f is increasing on an interval for any two numbers, x1 and x2 in the interval, it implies that the y values are increasing. So we'll be looking at the y values increasing. These are y values. F of x1 is less than f of x2 when this applies, when x1 is less than x2. And I'll show you an example of that in a second. A function is decreasing is when x1 is less than x2 and the y values are decreasing. F of x1 is less than f of x2. So let's look at an example of what I mean, or a drawing. So this is a drawing of a function where it's increasing and also decreasing. Let's start with increasing. It's increasing in this particular interval where x is equal to b, and it's going to be to infinity. And so if it's going in an upward direction, the y values are going in an upward direction as x are increasing, then the function is increasing. If the x values, as they're increasing, cause the y values to go in a line going a downward motion, then the function is decreasing. And if it stays the same within an interval, then it's constant, stays the same, a flat line. We look at, in this case, a horizontal line, then it is constant. So basically, decreasing means it's going downward, increasing means it's going upward as the values, the x values, are increasing. Now, also, if we want to look at a particular way of expressing it. For example, when you give me the answer, or when you write the answer, the function is decreasing. Let's look at this picture in the interval of negative infinity up to a. And so here's where it's decreasing, and it's decreasing, and how we write it is coming from negative infinity. Again, negative infinity is from this direction to the number right here, wherever this x value is, a. So when we write the answer, we write the x values. It is constant in this interval. We recognize that. So it's constant between, what's the x value? So we got to look up here, between a and b. And that's how we write it. And in this function, it's increasing from, and we use parentheses. Notice I'm using parentheses, no brackets. It's increasing from this point here, and it just keeps going on and on to infinity. So it'll be from b to infinity. And that's how you write the answers for increasing, decreasing, or staying constant. Now, you want to make sure you label where is increasing and decreasing. So I would say this is decreasing here between negative infinity and a. It's increasing, I'm gonna put an up arrow, between b and infinity. Excuse my infinity. It'll get better. My infinity's here. So this is infinity. And that's how you write your answers for increasing and decreasing, using parentheses and finding the interval where it's increasing and decreasing. Now let's look at an example to find where function is increasing and decreasing. And in addition, I'm going to show you where there's a max and a min. And so I'm going to show you some extremums. We call them relative extremums, max and min. It could be local or absolute value. or absolute, local or absolute max or min. So let me just give you how you get started. So you have this function, and we're going to kind of do is kind of sketch the graph without using a graphing calculator or a graphing tool. We're going to use what we learned in calculus and what we're learning now, how to sketch the graph. So the first thing you want to do is the first derivative test. You want to set the function or give the derivative of the function. Regardless of what the function looks like, you got to know how to find the derivative. In this case, we're going to be using the power rule. You may have to use the quotient rule or even the product rule to find the derivative. But since this is our first example, we're going to be using the power rule. And so to find the extremums and also increasing and decreasing, we're going to take the first derivative. And so when we take the first derivative of this function, we end up with 3x squared plus 2x minus 5. Now, in this particular example, to make it a little bit easier, we have this as a quadratic. And so I'm going to factor this and show you why I'm factoring it. So it'll be 3x plus 5 and x minus 1. That's another way of writing 3x squared plus 2x minus 5. All I did was just factor it in a way that we rewrite it and show you that sometimes when you can factor it, it makes it a lot easier to find increasing and decreasing of the function, and then also some other little things I'm going to show you a little later. Now, once you find the first derivative, you set that first derivative equal to 0. So that's the next step. So this step always happened. Take the first derivative, set the first derivative equal to 0. Since I factor it, I'm going to write it in blue. 3x plus 5 times x minus 1 is equal to 0. I've already put it in factor form. It's easy to solve for what x have to be. So we have two values. X is equal to a negative 5/3. That will give us from this first one, or x is equal to a positive 1. That's what we get for this particular, or the second expression for that first derivative to equal to 0. Now, those x values will help me get extremums. We'll come back to that. But we're first going to start with where the function increasing and decreasing. So the next step we should do, we should draw a number line and place where those critical points are. We call these critical points. Something happens here. Negative 5/3 and a positive 1. Now I want to put a note on these critical points. You usually want to find critical points in the first derivative like we did, and critical points is when the function is equal to 0, or I should say the derivative, the first derivative is equal to 0, or where it's undefined. In this example, we have no undefined terms, so we're just going to use the ones that are equal to 0. So don't forget, it's also when the first derivative is equal to 0 and when it's also undefined, and that will help us find those critical values, and those critical values will help us find max or min if it happens at those points. So now, once I have a number line, I put my critical values. I'm going to put this down. I'm going to put f prime of x. This is very important. I want to figure out within these 3 intervals. I have 3 intervals, interval 1, 2, and 3. Is it positive in that first interval? Is it negative? Is it positive in the second interval or negative? Or is it positive or negative in the third interval? And we know since it's equal to 0, we're only talking about the first derivative. We're not talking about the original function, just the derivative. Since it's equal to 0 at negative 5/3 and 1, we know that it's either going to be positive or negative in those 3 intervals. So how do you do that? Just choose a number in that interval. So we're going to choose a number in the first interval. So you can pick a number within the first interval, any number that you would like, and see the signs. We just want to know is it positive or negative. So for the first one, For this first interval, I'm going to put it in red so you know what number I'm choosing. I'm going to put -2. Why? Because -2 is in this first interval. And I'm going to plug -2 into f prime and figure out what the number is. I really don't care about the number. I just want to care if it's positive or negative. So this will equal to the value of 3 once I plug it into the derivative. Again, I'm plugging this into the derivative. -2 is being plugged into this equation, or you can say this equation. And I end up with 3. Now 3 is a positive number. So all the values in the first interval that we have is positive. I'm going to just put a lot of pluses so I know it's positive there. Now I'm going to choose a number in this second interval. Give me a number between -5/3 and 1 that you can use, any number. I'm actually going to use 0. So that's the number I'm going to use. And I'm going to put that into f prime. When I put in 0 into f prime, again, I'm using f prime. I'm underlining what's in red. It's going to give me 3 times 0 plus 2 times 0 gives me a -5. So every number in this interval will be negative. Every number, no matter if I use any number between that interval. Now I'm going to use another number in the third interval. So let's use another number in the third interval. It could be any number greater than 1. Let's use the number 2. So f prime, and we're putting it in the prime. Again, the first derivative, plugging 2 into here. I did the work for you. It's going to equal to a positive 11. Now, again, I don't care about really the number 11. I just want to care, was it positive or negative? And 11 is a positive number. So everything in this interval will be positive. Now, looking at another whiteboard, I put down positive, negative, positive for our intervals. This is our number line. And notice f prime is in red and the function f, the original function, is in blue. We're going to talk about it in a second. So now, once you do that positive, negative, positive, you just put down what direction positive look like. A positive slope, again, that first derivative also talks about the slope, gives us a positive direction. So all the numbers or all the in that interval will go in that direction. Negative will go in this direction, and positive will go in this direction. Now, as I look at that, one of the things I do, I look at the directions. I put these directions here inside each of those intervals, and it makes me look at the values at -5/3. So at -5/3, just watch this. I'm going to put this in red. It's going to look something like that. At 1, looking at a negative slope and going to a positive, it's going to look something like that. So it looks like that, watch this, at -5/3, we have a maximum. That's what max look like, a maximum high point. Again, those critical values, -5/3 and 1, will actually tell you if there's a max or min or something different. This one, for 1, look like there's a min because it's going downward. There's a minimum value. Okay. Now, what we want to do before we start the sketch of the graph, because we do want to sketch the graph, I want to figure out what is the y value at those critical points. What do you mean, Mr. C? You can go back to the original function and plug in a -5/3 in the original function, which is in blue. And I did the work for you. So when I plug in a -5/3 into the original function of f of x, it's going to give me 40/27 as a fraction. And you can try this on your own to make sure. Again, I'm also going to plug in the value 1 into the function, that the original function, which is blue. That's why I put the color blue. And that's going to give me a -8. I'm going to remember those. I'm going to remember those values. So what I have here is a -5/3. These are ordered pairs. 40 over 27, and then 1 and -8 as ordered pairs. Those are my X and Y values. Okay, we're going to look at that, and then we're going to graph. Now, also, you may want to do is find the y-intercepts and the x-intercepts of this function. So just real quick, let's find one of them since I have the original function. When you want to find the x and y-intercepts, you got to use that original function. You do not use the derivative. The first derivative helps you find the critical values and also if it's increasing and decreasing, but then you go back to the original function, which is blue, to find the y values of the critical values, and also if there's an x and y axis or we're across the x and y axis. So using the original function, if I say, watch this, we know that f, I'm going to put this in green, f of 0, when x is 0, our y value is -5. We can easily see that. So plugging 0 for all the x values, we end up with -5. So 0, -5, and this is in green, we can consider that 0, -5 is going to be my y-intercept. So this is my y-intercept. If you want to find the x-intercepts, you set the function f of x equal to 0 and solve for the x values. Now, in this case, I'm not going to solve for the we're across the x-axis because I'm just sketching the graph. What I'm going to use is my information that I have here, which is my intervals, my y-intercept, and my two values I get using the critical points, and then just give you a sketch of the graph very quickly. Now let's sketch the graph. So I'm on my whiteboard and I kind of made it more clean to see the different answers that we have so far that are significant. So what I'm going to do first, I'm going to draw my X and Y axis. Okay. And then I'm going to show you my local extremums that I got from my critical points. So let me label this -1, 1, 2, 3. And again, this would just be a sketch. To give you an idea how it looks. So let's start, what I'm going to start with is where the points are. I'm going to put that in blue. These are the points, -5/3. And we're saying that that's going to be a max, -5/3 and 40 over 27. So -5/3 is a little bit more than a -1 point something. So a -1, and in this case, we're looking at 2/3. So we're going to say it's exactly right here. And 40 over 27, we're going to say is exactly right here. So let's say it's right here. Again, we're just sketching. And we'll put it right where it says max. And then 1, -8, 1 is here. And -8 is way down here, way down here. Everybody agree? It's way down here. Give us, just doing a sketch. Now we're saying it's increasing from the interval, and this is how you want to write it. It's increasing, looking back at our intervals from -infinity to a -5/3, and also is increasing at this third interval, which is 1 and positive, go to positive infinity. It's decreasing only in one interval. That's the second interval right here, between -5/3 and 1. So that's our answer. That's how we write increasing and decreasing. So let's show that. So from -infinity to a -5/3, the first increasing piece is going to be going in this direction. And then it's going to decrease. Again, decreasing goes here. And then it's going to go back to increasing back here. So our graph will look something like this. This would be a sketch of our graph. Here's our max. This is a max. This is actually a local max. And this is also a local min. These are local min points. And how do we get this? We start graphing the max and min, the X and Y value using the original function from the critical values. Get where it's intersecting at. Now, in this case, what I didn't do a good job is where it intersects at. It intersects at 0 and -5. And so what I would do is find where -5 and 0 is right here, and then go back up. So my blue line is a little bit better than my orange line and gives me this sketch of the graph. So I'm going to go back to a clear whiteboard to show you what kind of answers you may want to write down. You want to write down where it's increasing. Again, you just write it down. It's increasing. Then you might want to use up arrow like this. From -infinity to -5/3. And it's also increasing at 1 and infinity for this particular function. And then it's decreasing from -5/3 to 1. So that's how I find increasing and how you write it. And then the extremums. This is what you should do next. There's a max. I'm going to put that in blue. You have a max. Use a critical point at a -5/3, and you get 40/27. Now that 40/27, because I plug in -5/3 into the original function, which was in blue that I showed you before, and then a minimum. Then let's write a minimum, and the minimum value, you're going to get 1, and if I'm not mistaken, it was -8. And if you look at the sketch of the graphs, not the best sketch, but at least gives you an idea. Go back to it. There's our max, there's our min point. We see where it's increasing. Again, looking back at our chart up here, it's decreasing. Looking back at our chart up here, it's increasing, going back here. And this is how you write your final answer. Well, if you want to just say where it's increasing, decreasing, and your max and your min points. Now let's look at another example. Now in this example, I'm only going to find where it's increasing and decreasing. We won't worry about the max and min. Let's just only find where is the function increasing and decreasing, and how do we write this function? And how do we write that answer, excuse me. So f of x is equal to x cubed minus 3x squared times x squared. And where is this increasing and where is it decreasing? So I rewrote the function on our whiteboard, and to find where it's increasing and decreasing, we're going to take the first derivative. So let's do f prime. So f prime, I'm going to write this one in black. It's going to be 3x squared minus 3x, if I did that correct. So let's make sure we did our derivative correct. Take the first derivative. Look like it's correct. And then the next thing we're going to do is set the function equal to, or the derivative equal to 0. So we're going to look at 3x squared minus 3x, set equal to 0, do some algebra to solve for that. So let me do it for you. We take out a 3 and an x, that's common in both. And we're left with an x minus 1 equal to 0. So the first piece of this will give me x is equal to 0. And the second piece, which is right here, x minus 1, will say x equals 1. So those are my critical values. And they could be max and min. But right now, we're not worrying about the local extremums or relative extremums. We're just looking at finding how to write where the function is increasing and decreasing. So in this case, the next step I would do, I'm going to do this in blue. So you can see this. I'm going to actually put our number line and put the value 0 here, the number 1 there, Those are critical values, and we have 3 intervals. There's sometimes you may have 4 intervals, 5, or maybe 2. In this case, we have 3 different intervals, 1, 2, and 3. And all we want to do is figure out, are the numbers positive or negative? We really don't care about the actual values, but is it positive or negative in those intervals? So for the first interval, anything less than 0, let's use a -1. That's a number less than 0. And I'm going to plug it into what, guys? Into the derivative. So notice I'm going to write down the derivative f of x, the first derivative. You plug it into the derivative. So plug in this -1 into the derivative here, or you could use it the where I factor at. And when I do that, it's going to give me, in this case, a value of 6. And 6 is a positive number. All the values in the first interval is going to be positive. Now we're going to choose some number in this second interval between 0 and 1. So give me a number between 0 and 1, and we're going to plug it in to the derivative. So let's write that in green. I'm going to use the value, let's use 1/2. That's between 0 and 1. I'm going to plug that into the derivative. So that goes into either this one or this one, doesn't matter. And you just want to figure out what is it equal to. So in this case, it's going to equal to a negative. I did it for you, -3/4. I don't particularly care about if it's 3/4, but if it's positive or negative. And so since it's negative, all the numbers here is going to be negative. And then the last one, I'm going to clear it out so we have a little more room here. And then we go to another whiteboard to show you how we write our answer. We're going to plug in a value greater than 1. So give me a number greater than 1. You can use 2, 3, 4, 5, whatever, 100. I'm going to use 2. So I'm going to use 2 in this particular region and put it in the prime. Again, plug the value 2 in the x values in the derivative, and it's going to give me a positive 6 if I'm not mistaken. Again, I'm just looking at the sign. So it's a positive number. So every number in this interval is going to be positive. Okay. So let's go to our next page of our whiteboard and rewrite what we have up here. So that showed the work. And what we had was 0, 1. And when we plug it into the derivatives, we end up with positive numbers here, negative, and positive, if I'm not mistaken. And so in this case, this is going positive, this is going negative, and this is going in a positive direction. So just a side note, I just want to show you a side note. Since it's going in a positive direction, it look like this 0 value will be a max, possibly a local max, and this 1 value going from a negative to a positive direction is going to be a min. Again, we're not worrying about max and min, relative extremes. We're just going to talk about how to write the answer as far as increasing and decreasing. But I just want to show you that side note there. So going back to our problem of increasing and decreasing, how you write the answer, and let's say the up arrow means increasing. So what intervals show where it's increasing? It's increasing in this region right here, and it's coming from negative infinity, and it stops at 0. Again, we use parentheses. And it's also increasing in this interval here. And it starts at 1, and it keeps going on and on and on to positive infinity. It doesn't stop. Now it's decreasing, and I'll use a down arrow for decreasing. It's decreasing in this orange area because it's all negative values. And how we write that? From 0 to 1. And in this case, this is where it's decreasing. This is where the function is increasing. And that's how you write the answer when you want to write increasing and decreasing. The last problem we're going to look at is we want to find the relative extremum, the max and min. Now, to do that, we also want to find where it's increasing and decreasing first, and then we're going to find the relative extremums. And so for this particular problem, it says find the relative extremum of f of x equal to 1 over x minus the sine of x between the interval 0 and 2 pi, which is good. So this is a good function that we're using because we're using some trig functions. So we need to know derivative of trig functions. So we're going to go on our whiteboard, and here's our function. Hopefully I wrote it correctly. So 1/2 x minus sine x. So let's first find where it's increasing and decreasing, and then write that answer. And then the second step, we're going to find the relative extremums. So to find where it's increasing and decreasing, we're going to take the derivative. The first derivative, f prime. I'm going to write this in blue so you know this is the first derivative. So this would give me 1/2, and the derivative of the sine of x is the cosine. So this would be minus cosine of x. Once you find the first derivative, you set it equal to 0. So we're going to say 1/2 minus the cosine of x is equal to 0, and then solve for x. So this gives me a negative cosine of x is equal to a negative 1/2. So the cosine of x is equal to 1/2. Now again, we're looking between 0 and 2 pi. That's important. So that limits our answers, because we could go infinitely many different answers if we didn't have an interval between 0 and 2 pi. So what x values between 0 and 2 pi, there was a cosine of x equals 1/2. So we could do the arcs cosine on both sides to get x by itself. And I've showed you that in previous videos and other videos that I have on our Mathlink website to look at that. And the answer would be, in this case, I'm going to write it in terms of pi. X is going to equal to pi over 3, and x is going to equal to 5 pi thirds. So if you use the unit circle, if you know how to use that, you understand that the answers will be pi over 3 and 5 pi thirds. And so those are our critical values, okay? Now, let's go and write down, do a number line, and pi over 3 is here, and 5 pi thirds is a little bigger. It's going to be over here. Now, again, we're looking at plugging in values. We're going to plug in 3 values because we've got 3 different regions or intervals. Here's 1, 2, and 3. We got to find values between there. And when we're going to use pi's, make it a lot easier. And we're going to plug it into the derivative. Again, that's the key. So f prime, I want to plug in values into f prime. And we're going to do 3 different values. So for the first region, for this first region right here, I'm going to use, let's say, a value less than pi over 3, pi fourth. So I'm going to use pi over 4. And I'm going to plug into the derivative. Now remember, the derivative was f prime is equal to 1/2 minus the cosine of x. So make sure you plug it into the derivative. That was our f prime. So I'm going to put this right here. Once I plug that in, that pi over 4, into the derivative, and I'm just going to tell you, it's going to give me, in this case, a negative number. Again, I don't care about what the number is. I just care about the sign. So in this whole first region is negative. Now I'm going to plug another value in our second region. Give me a value between pi thirds and 5 pi thirds. Let's see. What can we look at a value between there? And I'll say pi. Pi is between there. So again, we're going to plug in pi. And then for the cosine of x, we know that's going to be 1, 1/2 there, or -1 in that case. Make sure we get our right value. It's going to give me, what do you think? It's going to give me a positive value here. Okay. And then let's get a value that's greater than 5 pi thirds and plug it into our derivative. Again, this is our derivative we're plugging into. Let me see, 7 pi fourths. I'm just using that. You can use other ones, but I'm just going to use 7 pi over 4. That is bigger than 5 pi thirds. That's in a third. If I plug it into this equation, that's going to give me the cosine of that. That's going to be a bigger negative number than 1/2. So in this case, and you can use your calculators, guys, we're going to end up with negative values here. So now I'm going to erase what we show the work and show you what the answer would be. So let's start with increasing. So where's the function increasing? It's increasing between pi thirds and 5 pi thirds, right? Where's all the pluses are at. And where's the function decreasing? It's where the negatives are at. It's in this region and also that region. So how do you write the answer? It's coming from a negative infinity to, and it stops at pi over 3. And then also has another one that is decreasing at 5 pi over 3 to positive infinity. And so that's where it's increasing, where all the pluses are at, and decreasing, where all the negatives are at. So step 1 is done. We figure out where it's increasing and it's decreasing. Now we're going to look at the relative extremum. Is there positive or negative? Now I'll clean up my whiteboard so we can find the relative extremums. So this is what we found out, that this decreasing, so let me write that correctly, guys. Decreasing is that direction, increasing is here, and decreasing is there. So what do you notice? What do you think is a max or min? Do we have any max and min? It looks like we may have a possible local minimum point looking like this, going from what our green line at pi thirds. That looks like a min, and a max getting a high point going to a low point would be 5 pi thirds. Now, how do you write the answer? So what you have to do, you have to find, and this is our original equation, we have to find f of pi over 3, plug it into the original equation, and figure out the y value. That's the key, the original equation. So again, given the original equation, this gives me 1/2 times pi over 3 minus the sine of pi over 3. We end up here with pi over 6 minus, and I believe this is the square root of 3 over 2. And I'm going to leave it as that, as an answer for my y value, if I'm not mistaken, with using my pi over 3. For 5 pi thirds, we're going to plug it into the original equation. Again, the original one. This gives us 1/2 times 5 pi over 3 minus the sine of 5 pi over 3, which is a negative square root of 3 over 2. Gives me a positive square root of 3 over 2. So you say, Mr. C, how are you going to write this answer? I'm going to write it like this. This is equal to 5 or pi over 6 plus the square root of 3 over 2. You got to know your signs and know those values. So when you write the final answer, so when we write our final answer, this is how we're going to write our final answer. So for the max, and we're going to go to a new screen. So for the, let's start with the minimum. So the minimum, we said it was pi over 3. And the y value that we found, let's go back to our previous, it's this one right here. And you can write it as a decimal, but this is more precise. This is an accurate answer. Pi over 6 minus the square root of 3 over 2. That's our minimum. And then it's possibly a local max we're looking here would be 5 pi over 3 is our x value. And then the value that we found before, looking back here, will be right here. That's the y value, pi over 6 plus the square root of 3 over 2. Now, if you want to find and add and get common denominators and subtract, you can do that. We know the common denominator would be 6 for both the x for the y values. But for right now, I at least want to show you how to find the max and min of different functions. And so there's our max and min. Let's circle that since that's what we have here. There's our min. This is our max because you want to give the x and y value. And then we have our decreasing and where the function is increasing. Giving those values and giving those areas, you can now sketch the graph of this function. Now, hopefully this helped how to find increasing and decreasing within the functions, and also the relative extremums, max and min points, max and minimum points. If you have any questions, feel free to go on our website, the Mathlink, and look at our supplementary material that we have for you to look at some more examples and actually get a better understanding of finding the increasing, decreasing, and also the relative extremums. Again, let Mathlink bring it together.